All right, guys. So remember our plan for last class today and Friday. So this whole week is that we're going to be working through ACT and TSI questions. Last time we covered all of the kind of pre-Cali topics, if you will. Okay, so we're starting now on day 2. Okay, so most of this stuff is not necessarily going to be something that I directly taught you. It'd be more last year or algebra 2. Okay, so let's take a look at first page. We're doing some solving here. We'll do maybe 2 of these. Let's start with the first one. So it's a half A plus 10 is 6. What do you think you should do to get the A by itself if this is your equation?
Minus 10.
Okay, so we are going to times 2 and we are going to minus 10, but which one should we do first? I would do the minus 10 first. Now, you can do the times 2 first, but if you did that, you would have to times the 10 by 2 as well. Versus if you go ahead and subtract it across, then you don't have to. So I'm going to have 1/2 A. 6 take away 10 is -4. And then to get rid of the 1/2, which is a divide by 2, we'll multiply by 2. 2.5 will cross out. -4 times 2 is -8, which is answer choice G. Now, also keep in mind, you could take turns plugging in the answers and see which one gives you 6. So if you think you can do that faster than the solving that we just did, fine. All right. Go ahead and go down for me to this one right here. So I have root 5 minus x equals 4. What are we going to do? So to get rid of the square root, we'll have to square. So put a squared and a squared. So we'll do squared, squared. Squared and square root crosses out. I have a 5 minus x left. What is 4 squared? Okay, next step, got to get rid of that 5. How do we do it? Okay, 16 take away 5 is going to give me 11 next. Is that the answer? No, this is a negative x. Very good. So when I get rid of the 5, that negative means it's a -1 in front. So to get rid of it, I'm going to have to divide by -1 on both sides to cross it out, which means x is really -11. Okay, let's take a look at the one right before that. So first thing we notice is that instead of an equals sign, okay, you have a inequality. That means a greater than or less than. In this case, we see it's a greater than. So let's review how this is similar to solving an equation. The first thing that I need to do is I need to get my x's onto the same side. Now, when you're looking at these answer choices, do you see how the x comes first? So then I'm going to bring this x over to the left instead of adding the 2x to the right. So I want to kind of structure my answer like theirs. So if it's a minus x, I'm going to plus it across. So I have 3. What is a -2x plus a 1x? Minus 1x. Very good. Okay, then what would I do to get rid of the 3 in the front? Minus it. 7 minus 3 is going to give me -1x greater than 4. Okay, so far, this has been exactly the same as all the other solvings until now. How do I get rid of this number in front of the x? Divide it, and when you divide by a negative, do you remember what you have to do? Flip this guy. So instead of it being a greater than, when I divide that -1 across, it's going to go to an x less than. And then 4 divided by -1 is a -4. Okay, so that would be this one. Okay, but remember, if you multiply or divide by a negative on both sides, that's when you would do that little flippy step. All right. Okay, go ahead and turn the page. Yeah, let's do the word problem. All right, so it says on the first day of school, Mrs. Dubacek gave her third grade students 6 new spelling words to learn. On each day after that, she gave them 3 new spelling words. How many new spelling words would they know by the end of the 21st day? Okay, let's set up a little equation. How many did they have to learn day 1? 6. Plus, how much are they going to learn each day? 3. Now, you're probably thinking, well, we should do 3x. Okay, here's the problem with that. If I set it up like this, on the first day, they're doing 6 new words plus 3. And on the first day, they're not doing that. How many are they learning on the first day?
6.
Only 6. So I don't know if you remember, we actually did cover this, but you're going to put an x minus 1 to show that they're starting with 6. They're adding 3 every day, but not on the first day. So that's why we're going to put a minus 1 there. And then we want to know on the 21st day. So you would just plug that in right there. So they're learning 6 words on the first day, plus 3 more for 21 days, excluding day 1. 21 minus 1 is 20. What is 20 times 3? That'd be 60. And then add the 6 to it, it'd be 66. Okay, but remember that minus 1 is important that you include it if they're not doing that on the very first day. For this one right below it, I'm not going to do it, but remember you have a calculator. So if you want to just plug in the answers and see which one gives you equals 20, that would work. Okay, let's come down to simplifying. Okay, let's do this one right here. If I have a cubed on the outside, that means I need to do this times itself 3 times. So I'm going to have a 3x squared y cubed, 3x squared y cubed, 3x squared y cubed. So think about that parentheses as a stamp. You're stamping it 3 times. 1, 2, 3. First, multiply the numbers in the front. You have the calculator if you want it. What is 3 times 3 so far? And then times 3 again? 27. Then for the x's, you're going to add the little numbers. So I have 2 here, 2 more here, 2 more here. How many is that?
6.
X6. And then for my y's, I have 3. 3 more is 6. 3 more is 9. Okay. So some teachers would explain that you can times the 3 in, and that works great for the little numbers. But remember, on the 3, you're doing 3 to the 3rd power. So that's why I would say just stamp it 3 times, multiply it out, so you don't make that mistake. Okay. Do we know what these are? Absolute value. And what an absolute value does is you're essentially going to still do the subtraction. But if your answer comes out to be a negative, you're just going to turn it positive. So for example, what is 5 minus 3? 2 is 2 already positive? Then it's going to stay at 2. What is 1 minus 6? Negative 5. Then we're going to turn it to a positive 5. And then I'll subtract those answers. 2 minus 5 is negative. Okay, so you still do the subtraction, but then if it comes out to be a negative in an absolute value as your final answer, you would just switch it to a positive. Now, if it's already positive, you keep it that way. Okay? All right, go ahead and turn the page. Let's do the second one on the top here. Okay, we actually covered that in this class. You should have also done it in geometry. But think about your perfect squares. They're not going to give you a nice, easy, convenient list. Okay, but root 2, we're going to leave alone. But root 8 can be broken up into a perfect square. What perfect square can 8 divide by? Think about the little numbers. So 2 is not a perfect square because I can't square root it. 4 is a perfect square. Now, how will I get 8? I'll do 4 times 2. So I'm going to break it down into 4 times 2. And then what is the square root of 4? It's perfect. It'd be 2 root 2. Are we good to there? So my 8 broke down into 4 times 2. 4 is perfect. The square root goes back to a regular 2. Now let's do the 18. 18 can also divide by a perfect square. Which one? 9. 9 times what? 9 times 2, but then the square root of 9 is perfect. Okay, what is it? 3 root 2. And then now that they're all root 2s, I can add the numbers in the front. Now, the first root 2 doesn't have a number in the front. What number would go there? 1. So I have a 1 root 2 plus 2 more root 2 plus 3 more root 2 gives me how many? Very good. Okay. Go down to quadratic equations. Okay, those next ones you should be able to do. On this one, you see the squared, just stamp it twice and then times it out. Okay, but if you need help with that, raise your hand. All right, this one says, one of the following equations is that of a parabola. A parabola is just a U shape with x-intercepts -5 and 3/4. Which equation? So we did a whole unit on this back in, I think, October, that if my graph crosses the x-axis at -5, what would the parentheses or factor have said? Do you remember x what? +5. Very good. So put y equals x plus 5. If -5 is an answer, then the parentheses would have said x plus 5. Now, if the other one is a 3/4, remember we would do x minus 3/4. But then what would we do with the 4? Do you remember? Slide it to the front. So you would say this is x plus 5 times whoop 4x minus 3. Okay. So if you have the zeros, you can work your way backwards. You just have to remember that if one of them's a fraction, you slide it to the front. Then from there, we're just going to multiply that out. So let's start with the x. What is x times 4x? 4x squared, because we're multiplying, right? Okay, then I want x times -3. That's going to be a -3x. Then we're moving to the 5. What's 5 times 4x? 20x. And then 5 times -3. 5 times -3 would be -15. So based on that, I can eliminate 3 of my choices. And then if I combine these middle two, how should my 17 come out? Positive or negative? Positive, because if the 20 was bigger, 20 take away 3 would be positive 17. So it would be J. Questions on that? All right. How close are we? Are y'all, can we do a few more and just get it over with? Or do you need a little break? Good? Get them over with? Okay. All right, go ahead and turn the page, please. Okay, these top two are almost the exact same. They just don't have a fraction, so they should be easier. Let's go down to this one. Okay, so how do I find the area of a triangle? We covered this last class. 1/2 base times height. Now, in this case, our base is x plus 1, and our height is x. So my area formula would be 1/2 x plus 1 times x. And what does it tell me the area is supposed to equal? 20. Yeah, it says the area of the triangle above is supposed to come out to be 21. Now, you could solve this the long way. Okay, however, if I only have 4 answer choices, okay, you could also just take turns, plug them in, see which one gives us the answer. Let's try that method this time. So if I have a 3 here, what is 3 plus 1? 3 plus 1 would be 4 times 3. What's 3 times 4?
12.
12, and if I cut it in half, do I get 21? No. I also can kind of reason that's like kind of way too small, right? So let's try 7. Let's skip 6. We can always come back to it. Okay, but that was kind of way off, so I'm going to go up to 7. So if I put a 7 here, what's 7 plus 1? That'd be 1/2 8 times 7, and I need it to be 21. So 8 times 7 is 56. 56 cut in half, what are we going to get? 28, which is now too big. So that means it pretty much has to be 6. Okay, because this one came out too small, this one came out too big, then we know it's got to be the one in the middle. Okay. All right, next one. Let's say that we're doing this guy right here. Do y'all remember how to find y-intercepts? Just put it in your calculator and look for where it crosses. So y equals, you get a calculator for the whole test. So I'm just going to type this in. You can use the pretty fraction for the half if you want to, but you definitely don't need to. And then look at the graph. I want the y-intercept. Then I want to know where this graph crosses the y-axis. Okay, and it looks like it crosses right here. What number would that be? -9. Now, the 1/2 and the 3, okay, these are x-intercepts. Okay, so if you want to just sketch that graph here, okay, it went like this. This is -9 is the y-intercept. Okay, versus these two would be considered x-intercepts. And they could ask you for either one. But remember, you have a graphing calculator, so do it. Okay. All right, go ahead and turn the page. All right. Next page, go to systems of equations. Okay, I'm going to show you 2 methods for solving systems of equations. The first one is called elimination. We're going to do the word problem. So it says, Richard bought 3 slices of cheese pizza and 2 sodas for $8.75. Let's write ourselves a little equation. 3 slices of pizza is going to be 3x. 2 sodas is going to be 2y. And he spent $8.75. Okay, now let's talk about Jordan. Jordan got 2 slices of cheese pizza. So that would be 2x. And he got 4 sodas, 4y, for $8.50. Okay, here's how elimination works. You should have covered this, I think, in Algebra 2. Okay, in your system, here's our goal. We want to add up the columns so that either the x eliminates or the y eliminates. Now, if I add them up right now, 3x plus 2x is 5x. That doesn't cross out. Same thing for my y's, 2y and 4y, that's 6y. So I want to rig the system so that when I add them up, one of the letters is going to go away. Let's do it with the y's. If this is a positive 4y, what would I need up here to cancel it out? -4y. I already have a 2y. So what would I need to multiply the top row by? -2. Okay, so multiply -2 across the whole row. Now, the bottom row, we're keeping it the same. So my 2x plus 4y, I'm just going to rewrite that, is 850. Okay, we're keeping that one the same. But for the top one, we're going to times a -2 all the way across the top, starting with the 3x. What is 3x multiplied by -2? -6x. What is 2y if I multiply it by -2? -4y. And then 875 multiplied by -2 is -1750. Now we're ready to add them up. Okay, I'm going to go ahead and cross the y's out because I know those are going to eliminate. What is -6x plus 2x? -4x. And then what is -1750 plus 850? -9. And then to solve, what do I do with that -4? Divide by -4 all the way across. Now remember, this is money. So if it doesn't come out to be a nice even number, that's fine. 225, that would make sense. Now, X was the cost for a slice of pizza. But we still need to find the cost of what? The soda. So let's go ahead and plug our 225 back in for pizza and see how much a soda is. So if I'm doing, let's say, the bottom equation. Okay, remember, we know 2x plus 4y needs to be 850. Then if this is 225 and she bought 2 of them, how much would she be spending on pizza? Just the bottom row. That'd be 450 plus 4y equals 850. So I'm taking that bottom combination and I'm saying, if I know my pizza is 225, then 2 of those pieces would be 450. 4y equals 850. We're going to minus that across. What would we get? $4. And then if I can get 4 sodas for $4, how much is each soda? $1. So divide the 4, your y is 1. Okay. Then it says, all right, well then how much would an order of 1 pizza, so put 225 into your calculator, plus 3 sodas that are $1 each. So that'd be 225 for the first piece of pizza, plus 3 sodas, and if they're $1 each, you're just adding 3. So it'd be $5.25. Okay. Now, I'm not going to do the top one with you, but when you stack these, which letter is already going to cross out? The X's. So if it's already set up where one of the letters is going to cross itself out, then don't worry about trying to multiply a row. Just let the one that's going to cross out. Okay? All right, go ahead and turn the page. We have made it to the last page for today. Okay, let's do the second one. So it says the yard behind Cindy's house is rectangular in shape and it has a perimeter of 72. The formula for perimeter is 2L plus 2W and it equals 72. Okay, so perimeter, you're adding up all the sides, but if it's a rectangle, you're going to have 2 lengths and then 2 widths. Okay, it says if the length of the yard is 18 feet longer than the width of the yard. So let's write an equation that says that the length of the yard is L and it's 18 feet longer than the width, then it'd be the width plus 18 more. Okay, so look at that, see if that makes sense. The length is 18 longer than what? Longer than the width. So you do W plus 18. Okay, then if these kind of follow the same structure, where the L and the W were both on the same side like this one, you could do the add them up thing. That's fine. Okay, but there's another method of solving called substitution. where you would say if the length is equal to W plus 18, you would put it in this spot. So instead of a 2L, I would put a W plus 18 into that position. And then from there, you can just solve it. Now, why is this equation solvable, but the first one wasn't? This one had how many letters? L's and W's. But once I substitute the L for a W plus 18 in its spot, now this equation's only got W's in it. Well, then I can solve and combine like terms and blah, blah, blah. So let's times the 2 in first. 2 times W is 2W. What about 2 times 18? 36 plus 2W is 72. Next, let's combine like terms. I have a 2W and a 2W. They're already on the same side. I just got to put them together. That'd be 4W. Plus 36 is 72. What would my next step be? Minus the 36. 4W equals 72. Take away 36 is how many? Use your calculator on that. 36. And then divide the 4 out the way. What's the width? 9. Okay, now, the width is 9, but it's asking me for the area. And remember, to find area, you need to do length times width, which means I really need to know both. Now, go back to this right here. What do I know about the length? It's 18 more than the width.
9 plus 18.
Uh-huh. Very good. So if the width is 9, 9 plus 18 more means that the length is how many? 27. Very good. And then you do area equals length times width, which would be 27 times 9. Okay, so that method is called substitution versus the other method that you learned is called elimination. Okay. Before I leave you alone, will you set up the equations for the one right above that? Because if your equations are wrong, your answer will come out wrong. All right, so first question, how many people are on this little trip getting lunch? Then X plus Y is 18. Okay, that's your first equation, is you're just counting up people. Now, let's say all of the X's, they got a soup, and all of the Y's, they got a sandwich, okay? So X's, let's label it, is for soup. And then this one is for the sandwich. Okay, now let's talk about money. How much did each soup guy pay? What's the soup cost? So that's for the sandwich, yep. So the soups are $4.50 each. And the sandwiches are $7.75 each. And then how much did they spend altogether? The cost of all the lunches was $113.50. Now, when you solve it, is it rigged right now that the X's or the Y's will cross out? No, but if I want to know how many sandwiches, that means I need to get rid of the soups, right? So if the bottom row for soups is a positive 450, what will you multiply the top row by to eliminate it? Negative 450. Okay, so I'm going to put here, you're going to multiply negative $4.50 on this row. Okay, but the bottom row, you're going to keep the same. Okay, and that method is called elimination. All right, good job. So remember, everyone who's not a senior, your ACT is next week on Tuesday. Okay, and then if you are a senior, as long as you did the examples we did together, you're good. It would help me out a lot, seniors, on your front page. Will you write in big letters, senior, so that I remember that? Okay. All right. You have like an hour. Yeah.